Ok. Então, bem-vindos e bem-vindas. Hoje o seminário é em inglês, então eu vou procurar falar o máximo possível em inglês, tá? Daqui a pouco vai passar a lista, eu estou para receber, e aí eu passo junto, tá bom? So it's a very pleasure to have Professor Daniela Cavalcoli. It's a complex name even for Italian people. Okay, so Professor Daniela she's an associate professor at the Department of Physics and Astronomy, Augusto Righi. And she works with physics of matter. She's also delegate of mobility of teachers, students, and professional staff, Alma Mater Studiorum, Università di Bologna. So, as I told you, she's, since November 2021, she has been delegated by the rector for the mobility of teachers, students, and techno-administrative staff. Presently, her research focuses on innovative materials for renewable energy, particularly in photovoltaic energy conversion and solar cells. Her primary interests include the investigation of optical and electronic properties of advanced materials and the study of semiconductor nanostructures. These materials and structures have diverse applications in photovoltaic conversion, light emission, and microelectronics as well. So it's a subject very important nowadays in terms of the transition of energy that we live. She has served as a work package, P, leader and has participated in numerous national and international research projects, collaborating with various universities and research centers across Europe. She is the author of several publications in international scientific journals and is an expert evaluator for European and national projects in the fields of renewable energy and nanomaterials. In her role as delegate of the rector for international mobility, she is actively engaged in strategic initiatives promoting global mobility for students, faculties, and staffs. So it's very pleasure to have you with us, Professor Daniela. And this is a seminar, a very traditional seminar that we held every Tuesday in this period, 16 o'clock. I think we've got 1 hour of talk and more 30 minutes of discussion. It's all right. So the floor is yours. Thank you very much for coming.
Thank you. Thank you so much. Thank you so much for the invitation. Thank you so much for the introduction. So what I'm going to explain you is our recent path in the development of a new bachelor in material science. So in order to go through this story, I will also try to introduce you a little bit the University of Bologna. So I will show you how the University of Bologna works, how it is done, his history. So we will start from the history. I will not explain everything because, as you will see, it's a very, very long history. I will focus more on the international perspectives, so the international projects and the mobility of the students, which is the field in which I am involved, as you noticed, and I will show you some data regarding the number of students, the teaching staff, and so on, and the research. So then I will enter more into the details of this project, which is a Bachelor in Material Science, on the motivation and on how we organized this bachelor, and I will stress some keywords like innovation and promotion and communication and go through some conclusions. So let's start with the University of Bologna. Going through the numbers, it's very fun to see that more or less the number of our university, of the students in our university, are similar with the number of your university as far as I've seen on the web. I think the main difference is in Bologna, we have around 80,000 students, over 400,000 citizens. So Bologna City and Bologna University overlaps a lot, either in the history, because also the history of the city and the history of the university went more or less in the same path. And as far as we know, Bologna University is the oldest university in the Western world. For this reason, it's called Alma Mater Studiorum, the mother of all the universities. So I have also a nice video that I will show you later on when we will stop speaking about University of Bologna. But as you can know, the history is a very long history because it started in 1088. So here we know about the existence of the university due to some paintings and bassorilievi, I think that this is also the English name, bassorilievi, that were representing the students and the rector of the university and the professor. It's also nice to mention that the rector was chosen among the students, because the students decided about their professor and paid their professors, and so they choose the rector at that time. Now things are changed, as you know, as you probably know. So this is the story, and I will not go through all those steps. I will just mention that in many steps, the university tried always to establish the freedom of the research with respect to the political power. And the political power at that time were mainly the religious power in Italy and in Bologna in particular. The last step I would like to mention is what is named in Europe the Bologna process, which is a process signed where all the rectors of the university, many of them, around 50 rectors of the university, signed together this Bologna process that established the duration of bachelor and master program at the same level in Europe, and tried to establish some common path for all the different bachelor and master around Europe, which is an important step in order also to achieve a good mobility program between students that move around Europe. We have had very recently the anniversary of Bologna process and so on. At a time, University of Bologna is not only a matter of tradition and history, but is also a university that really looks to the future. And in particular, since around 30, 40 years, the university became multi-campus. So the University of Bologna is not located only in Bologna, but we have some section in Ravenna, Forlices, and Rimini. So typically in the south of our region, which is called Emilia-Romagna. These are places in Romagna. Each of these places are very famous for something, and there we put the relative courses. For example, in Rimini is on the Adriatic Sea, is a very famous touristic place, and we have there a course on tourism, on sustainable tourism, and so on. So, and that's the same on the other parts. So, looking at the international perspectives, so University of Bologna signed a series of accords internationally of framework agreement with several universities, and this is a link on an interactive map where you can see the agreements between the University of Bologna and the other universities signed at that time. So as you can see, the biggest part is, of course, here in Europe, because in Europe we have the agreements for the Erasmus project, which is a very big project for mobility of students, professors, and staff around the university across Europe. But as you can see, we have also several agreements in basically all the parts of the world. And what is also important to mention is how we promote this mobility. So this is just a zoom of this map. And in Europe, basically, we finance the mobility with the Erasmus project. Our numbers are record number because we are able to send abroad 3,500 students, and mostly the same. These are incoming students, so students that come to Bologna from other universities in Europe, and these are the outgoing students, and we are the first university in Europe for the number of exchange students under the Erasmus program. But not only in Europe, as I showed you, we have several agreements with a series of universities. For example, here I zoomed in the part of America, South America, and also Brazil, as you can see, how we do promote this exchange under a program that we call Overseas. Overseas program is a program in which we put some funding to promote the mobility of our students that can move in each one of the universities with which we sign those agreements. Typically, in those agreements, it's just written that we want to cooperate to establish mobility, to exchange students, researchers, and professors, and so on. With the students, we put some money to promote this kind of exchange, and we are able to move around 300 students per year under this program. Also, really a few words about the ranking. You know that universities are ranked by different ranking protocols and categories. So in Italy is the second a second university in Italy among the mega universities. In Italy, we distinguish the university between mega and medium and small. We are among the mega universities because 100,000 students is a very big number in Italy and also in Europe. And it's, for me, it's also important, also for what I do for research, to mention that we are the first in Italy and the 9th in the world for the green metric ranking. The green metric measure how much the university is sustainable and adopt some projects and practices to improve sustainability. So the green metrics is how much we are green, in other words. Then there are other rankings, the QS. Typically, we are quite well placed in Italy. As you can see, in 16 disciplines, we are the first in Italy because the QS ranking divides the ranking for disciplines. So, as I told you, how many students, apart from the number of students, it's worth mentioning how they are distributed among the different programs. We have a system which seems to be quite very similar to your system. We have a bachelor, so which is first cycle, and we have a second cycle master, 2 years after the bachelor. We have after the master, so you have to also be a graduate student from the second cycle. You can approach PhD. So we have 51 different PhD programs on different disciplines, specialization schools, and masters. These are professional masters. So this is what we call as postgraduate training. So basically, I think the system is very similar to your. How many students in the programs? More women than men. Many of them are international. We are now around 15% of international students. 15. So how we are organized? We are organized in departments. So each department is in charge of the research and the teaching activity that is carried out within the departments. So we are divided into 31, and those 31 are divided in 5 different areas. So what I would like to mention is, of course, the scientific area. And the red one are the 3 departments that are involved in what I will tell you in a minute. So regarding this new bachelor on material science. So as you can see, each department is really focused on a specific research. We have different areas that you can see here: medicine, technology, social studies, humanities, and science. Apart from that, we have several interdisciplinary research activities that involve different kind of researchers across the different universities. So what about the teaching? As I told you, we have in reality several international students because recently, let's say in the last 5 years, we moved to teaching in English. And of 260-degree program, basically 1/2 of them are international. International means not only taught in English, but also international in terms of double and multiple titles. I don't know if you are familiar with this process, but we have some agreements with other universities by which students spend 1 semester in Bologna, 1 semester, I don't know, in Paris, another semester in Germany, and finally they will get the same title. So we arrange a teaching program across 3 different universities. We promote the mobility, we finance the mobility of students, and we plan the study plan, we design the study plan in such a way that their final graduation can be recognized by the 3 universities at the same time. So there is only one discussion for the 3 universities. This is a very nice are very nice programs. Typically, the students enjoy very much this kind of process. They had the opportunity to go around in different places in Europe. We have, however, we don't have those kind of programs only in Europe. We have also those multiple titles, more rare, but we have also multiple titles with other countries. For example, there is a titles with Chile, with 1 university in Chile. So, as I told you, we have those different cycles. We have only a special single cycle courses. It's typically medicine. Medicine lasts 6 years, and it's only 1 program, 1 degree program. Okay, this is the number of staff. Just to the teaching staff, the distribution between men and women that is reversed with respect to the number of students, as you have seen before. And this is how the teaching staff is divided among full professor, associate professor, and researcher. So, okay, of course, we try to promote also and discuss the gender balance. I took this from a previous European project. Probably also Olivia knows this kind of picture, because I don't know if it is a common problem. Probably it's common also in your university, but in the STEM disciplines, we have few girls. Not so many girls with respect to men. And so we want to promote the participation of girls to science. Science is a girl thing, but we have also from several years the reduction of the university fee for women that choose STEM courses. A STEM course. So we have a sort of promotion. Apart from the research which is carried out within the departments, we have some interdisciplinary activity that refers to themes and topics that are interdisciplinary. For this reason, we have several research projects in this field. These are fields that are strongly related also with societal challenges. And so for this reason, in this section, we have several disciplines working together. So here, for example, in the field of climate, energy, and mobility, we have an important PhD course, which is administrative in our departments, but involves 12 departments on climate change. And several also departments, not only scientific one, are involved in this important PhD program. This is just to give you an example. So before now leaving the University of Bologna as a general topic, I would like to show you a movie. Okay. I think I can also, okay.
Born to develop free and independent study.
That drives us to innovate, always.
Created by students.
For students.
International by vocation.
By choice.
Growing together in the city of the porticos, exchanging knowledge and know-how.
And emotions.
The symbol of a city. A resource for the local region.
Pero presente en el mundo.
Committed to knowledge, discovery, invention.
Continuing to reach new heights.
Surrounded by beauty, history, and tradition.
Yet always original and creative.
I am Alma Mater Studiorum, University of Bologna. I have been looking to the future since 1088.
Of our university. In the last picture, you have seen a big ceremony that we do each year for the PhD students. So when they finish their path, they go or in the main piazza of the city, or in the aula, in the main lecture room of the university to make this celebration. So they have all the toga and hat and everything. So I will proceed with the presentation, which is here. So let's move to the other part. So I will wait at the end for the questions. Okay, we'll go on. So now what I'm going to do, I have also another movie I will show you later, is to speak about this, this bachelor degree program in material science. This project has been done in collaboration between 3 departments: our departments, physics and astronomy, the Department of Chemistry, and Department of Industrial Chemistry, as I showed you before. Just a few motivations why we have to deal with materials. So basically, materials define our identities. I have already always defined the our identity. If you think about the past, you mentioned the Stone Age, you mentioned the Bronze Age, and so on. So going on with this discussion, we can think about, for example, 1950 as the Silicon Age, because silicon is everywhere in our devices, and also in the renewable energy sector. And the future, so the next century will be, what will be? We don't know still yet, but it can be, for example, the photonic age or the age of quantum computers. But in any case, each age has been characterized by a special material class. So it's important also how we use the materials, and this is another important topic, even if you think about to sustainability, to mining, and so on. So as I told you, we work together with 3 different departments. You see here some picture of the students within those departments. So we have chemistry, industrial chemistry, physics, and astronomy. They are located in different positions in Bologna, and in particular, our department, the physics and astronomy, is already in the main center of the city, while industrial chemistry and chemistry are now located in a position just away from the main center of the city, but it's a new building, it's a very nice building because it contains very nice new lab for the students. So the topics, we go through the study of the physical, chemical, structural properties of condensed matter, and we try to link micro with macro. So the nice game to play in condensed matter physics is that you are able to model the material, to study the properties of the material starting from the very micro. So the length scale, as you see, we lost this one. So the length scale, as you can see, varies over several order of magnitude. So you can try to understand the macro world with the knowledge of the micro one. So for this reason is also very important. So another reason why it's very important to study material, as it was mentioned in the introduction, I work with materials for renewable energy applications. So in particular, I work for materials that are used for solar cell. I've seen that you have a nice photovoltaic implant here in the campus. I went through it. So what is nowadays technologies is a technology like this one and like the one that you have in your campus, which is based on silicon. What we are doing now is to study something that can overcome the properties of silicon, and in particular, the new class of material are material based on perovskites. Perovskites means a class of material which is a wide range of different organic and inorganic or hybrid material. Very nice to study. Basically, the research on this material is something which is quite new, but they already have now an efficiency that overcomes the ones of silicon. The advantage is that while silicon, in order to be built, to obtain silicon, you need around 1,400 degrees C in a controlled environment. Perovskites is something that we grow in our lab at 80 degrees. So it's something that you prepare from liquid phase, something very easy to prepare that requires a very small energy budget. Unfortunately, this material is very promising from the point of view of efficiency, so it's very efficient, but still has a lot of problems regarding stability. So there is a lot of things that we can study on these materials. And this is just an example of a tandem cell with silicon and perovskites. So what is worth studying are, for example, the interfaces and so on. This is just an example of those kind of application. I put this example because this is my job in some way. But of course, you can mention several examples like artificial intelligence, nanotechnologies, biotechnologies, and devices. So I will go also through an example on AI. What is the methodology we use? This is also quite important because it's an innovative, in our view, way to look at the things. So in our course, we use several approaches, theory and experiments, simulation and modeling, to understand the properties of materials in order to obtain applications, and we use the strong correlation that exists between physics and chemistry. So we designed this course together with our colleague from the chemistry department. This was not simple at the beginning, I have to tell you, but among the application, I already mentioned, okay, computers, silicon microelectronics, but you can also mention, for example, tennis. You cannot achieve the velocity of a thinner game without an object like this. So the resistance of the material, the development of new materials is also based on experiments, theory, and this kind of studies. So the applications can be, in reality, in several courses. So this is the list of exams. I don't want to bore you with all this list. However, I would like just to show you the innovation and what is different from a standard course. So in all the STEM courses, you typically see mathematics, physics, general chemistry, and so on. What is nice to see here in this study plan is that we inserted the study of materials since the very beginning. Material Science 1 and Material Science 2 at the very beginning. So the students should not wait up to the end of the course in order to go inside the properties of materials. And so in the second year also we have data science, organic chemistry. We have several specific courses for materials. So also here you read, for example, physics lab for materials, material characterization, and so on. So it's really focused on the material starting from the very beginning. Another important point is on the third year, in the second semester, while the students, basically in the second semester, they do not take some traditional courses, but practicum, internship, and I will show you what is this practicum. Okay. What is practicum? In practicum, we decided that we, together with the students, speaking with them and regarding the possibilities that we have, we choose a material system. This material system is seen by the students through different steps. So, modeling, and fabrications and characterization. So they take the same material. For example, they use perovskites, a particular perovskite compounds. They model these perovskites, they fabricate these perovskites, and they characterize by microscopy, by spectroscopic technique, and so on. So they play with a different approach, theory and experiments and so on. Then they can do to have an internship in the third year. For example, in a company, here I'm mentioning the area in which we are particularly brilliant in Emilia-Romagna, so automotive, I guess you know Ferrari, and packaging. We are the packaging valley in Emilia-Romagna, so we work with machines for packaging, data centers, food, of course, printing, 3D printing. There are several applications of materials in the automotive sectors for developing, for example, light materials, but resistant material. They can do also the internship In a research center, we have in Bologna the CNR research area, which is this one. We have ENEA, which is a center that studies energies typically, or at the university in our 3 departments. So this is basically what they do at the 3rd year. Then what happens next? So of course, after the bachelor, they can even go to work. It's not so usual. Typically, our students go on with the master. And so they can go on with the master course in physics, chemistry, industrial chemistry as well. And also these new courses, this will start next year, is focused on advanced materials and batteries. So material for energy storage, basically, and these name that combine a general approach with a particular application, which is batteries, is due to the fact that recently a new lab started at the University of Bologna with a strong participation of Ferrari company, and this lab can be used by the students that will go on with these master courses. This is still in progress, but it will start next year. So then what to do next? Again, next. So, of course, a typical path of a student coming out from a material science bachelor and master can be to go to work, to go to a company, or to start a startup, or to go to research, so to do the PhD, to go to do research, to take the Nobel. So, of course, the Nobel Prize in material science does not exist. However, if you look at the recent Nobel Prize in physics and chemistry, they are Nobel Prize that deals with condensed matter, with the material science. So for this reason, we used this jump to the Nobel Prize in order to explain the use of materials, also to promote these new diploma courses, and we have done some events related to Nobel Prize in material science. I'm sorry that the locandina, the leaflet is in Italian, but this was a seminar on quantum dots. It is alla scoperta dei premi Nobel nella scienza dei materiali, so Discovery Nobel Prize in Material Science. And so we invited people from other universities or departments, and we have done this kind of event, one per year. The other events we organized was on AI, artificial intelligence, and this kind of event deals with the use of artificial intelligence in order to discover new materials and to obtain new materials. So we have had some talk by some of my colleagues. So these are 2 colleagues in our section which are on the simulation side, and Ivan Rivalta is a professor from the chemical department. So, as I told you at the very beginning, it was not a simple task to create these new diploma courses, because sometimes, probably you know, when you speak with people from the chemistry department, they use a different terminology to describe the same things. So sometimes it was also an important problem of language that we have had to overcome in order to create these diploma courses. However, we succeeded in doing this kind of path, and finally we will have the first graduate students in July this year, because it's 3 years that this course is ongoing. I try to explain you methodology, approach, courses, interdisciplinarity, and I showed you some data and some characteristics of University of Bologna in conclusion. So I would like also to thank you a lot for inviting me. I will show now also the movie regarding our diploma courses. I would like also to thank, I didn't mention here, the project for which I am here. After the seminar, I will move to Campinas University. Either São Paulo, either Campinas are part of a project which is financed under a resilience and recovery plan of this was a plan funded by European Union that helped several countries in Europe to recover after the COVID period. And within this program is financed this project, which is mentioned, is named Heritage for Future. Within the project, there is also University of São Paulo and University of Campinas are part of this project as well. So I would propose to show the movie up to, and we wait so for questions. I wait for, okay? I'm sorry that this is also in Italian.
Okay, practice. Just.
Lo sviluppo della società umana è intimamente legato ai materiali. Usiamo infatti i materiali per definire le tappe della nostra storia. L'età della pietra, del rame, del bronzo, del ferro. Pensiamo all'ascesa di computer, smartphone, celle solari. Tutto questo è in ultima analisi riconducibile ad una classe di materiali, quali i semiconduttori ed in particolare il silicio. Possiamo quindi definire la nostra epoca come l'età del silicio.
Le sfide della nostra società nei settori della transizione energetica, del digitale, della medicina e dell'agroalimentare passano dai materiali. Immaginate di progettare nuovi materiali per celle solari, batterie, sensori biocompatibili o computer quantistici, oppure materiali ultraleggeri ma resistenti per automotive o biocompatibili per applicazioni biomediche. O ancora materiali ecocompatibili e sostenibili per uno sviluppo che non alteri l'equilibrio del pianeta.
Per accedere al corso di laurea dovrai superare un test TOEIC e iscriverti al corso come previsto dal bando pubblicato sul nostro sito. Studierai la progettazione e realizzazione di nuovi materiali. Per farlo si parte dalla conoscenza della struttura dei materiali, dalla scala atomica a quella macroscopica e delle loro proprietà fisiche e chimiche. Il corso di laurea in Scienza dei Materiali all'Università di Bologna ti permetterà di acquisire queste conoscenze integrando aspetti sperimentali e teorico-computazionali.
Negli studi ti accompagneranno i docenti di 3 dipartimenti del nostro Ateneo: il Dipartimento di Fisica e Astronomia, il Dipartimento di Chimica e il Dipartimento di Chimica Industriale. Questa collaborazione è unica nel panorama italiano e ti permetterà di studiare in un ambiente realmente multidisciplinare. Il corso ti fornirà una solida formazione scientifica tra fisica, chimica e tecnologie industriali. Il primo anno studierai matematica, fisica, chimica, informatica, assieme a corsi caratterizzanti trasversali che introducono la scienza dei materiali.
Dal secondo anno entrerai in contatto con la chimica fisica dei materiali, lo studio della teoria quantistica della materia, le tecniche di caratterizzazione sperimentale dei materiali e le tecniche di data science e analisi di grandi quantità di dati. Tutto questo lo potrai fare nei laboratori dei 3 dipartimenti dell'università, dotati di tecnologie moderne e avanzate. Al terzo anno acquisirai competenze di modellistica, progettazione e sostenibilità dei materiali. Potrai svolgere il practicum, in cui metterai in pratica le tue conoscenze attraverso un'esperienza diretta nei laboratori dei gruppi di ricerca dei 3 dipartimenti. Questa è un'esperienza unica offerta dal nostro corso di laurea.
Infine potrai svolgere un tirocinio o all'interno dell'università o in aziende ed enti di ricerca, sviluppando lo studio di uno specifico argomento nella scienza dei materiali, che ti porterà direttamente alla discussione della prova finale. Dopo la laurea potrai o entrare nel mondo del lavoro oppure proseguire con gli studi.
Lavorerai presso aziende che si occupano di progettazione, produzione e caratterizzazione dei materiali per settori strategici della nostra società.
Oppure potrai decidere di completare la tua formazione nella futura laurea magistrale in scienza dei materiali o in uno dei corsi di laurea magistrale offerti dai dipartimenti di fisica, chimica e chimica industriale.
Studiare scienze dei materiali all'Università di Bologna
Ti darà la possibilità di far parte di un ateneo tra i migliori delle classifiche universitarie internazionali
Ed il più antico del mondo occidentale.
Ti aspettiamo a Bologna all'Alma Mater.
Thank you, Daniela. I think we can have come to the questions right now. Please, Sean. I have a couple of questions as well, but I give you the floor for you. Kindly.
Welcome. So Daniela, thank you for your talk. I'm curious with the construction of the curriculum, in the sense that you show a lot of different disciplines there, or courses, physics, mathematics, and chemistry. There's no biology, no, but yeah. But there's as you said in the first semester, the material sciences course. Yes. And I'm curious with the negotiation between the three departments about the contents and how to overcome the the contradictions that or the different language for the same objects as you mentioned. But I don't know. I think it's a very difficult part of to realize a program like that.
It was a difficult part of the job. We were a group of physicists, chemistry, and of the industrial chemistry department. And sometimes, you know, also to agree about the language is difficult. And also to agree about something, I don't know, chemistry people said, okay, quantum mechanics is our job. And so we, as a physicist, we say, oh no, probably not. This is not the case. So quantum mechanics is our. So finally, we designed the course in such a way that you have half of the credits. The credits is what we use in order to count the hours and so on. Half of the credits were of physics and half were of chemistry, apart from the credits that we mentioned for mathematics and so on. It has been quite a long procedure, so we have had several discussions, several meetings in order to agree on this side. Finally, what helped us a lot was also to find textbooks. Textbooks on material science. You know, material science is quite a new experience in Italy, in the sense that we don't have many courses of this kind around Italy. There is only one with big tradition in Milano, University of Milano, Bicocca, but around Italy is not so frequent. We also started with this procedure because there was a national law about the possibility to start and to give to deliver a degree on material science. So we started with this idea, and we started also discussing about the textbook that are adopted around Europe. For example, in UK is a quite a common experience also, material science in Cambridge and so on. This helped us a lot.
So thank you for the presentation. And my question is about also the curriculum. And what we see that you have mostly 5 different courses in each semester. So it's equivalent of we have here. But when you put it together, for example, mechanics and thermodynamics in one single course for one semester. So here we fight ones against other, because we have 6 hours of mechanics, then 6 hours of thermodynamic. In the second semester, you have together electromagnetic and optics, also together in a course. So what we see most of the time that you are going to pass through the subjects, but how deep you can go if you have few hours only to show the subject. So I'm worried about how deep you can go in the subjects or in the mathematics, or if mathematics is not the subject of the course. Because when we think about a traditional physics courses, most of the people are very worried about the mathematics, how deep you go in solving the equation, how many examples you can show, how many things you can go. But when you put so many content together, I'm interested in how deep you go on mathematics of these subjects.
It's a very good question because it's challenging, and you have to think that each of these courses is 6 credits. 6 credits means, in our language, around 50 hours of lectures. 50. No, not per week, in the whole semester. 50 per semester. We have formally it's 48 hours for semester, but it can become more if you include also exercise or lab hours. For example, I teach this course mechanics and thermodynamics for them, and typically, yes, it's around 50 hours. How deep you go? This is a very also good question because, of course, if you compare the same course that is given for the physics course, the students of the physics course receive more deep insight into the mechanics and thermodynamic section, and they also have more hours, so more credits. Here, if you have to include also something on material science, data science, so other topics, of course, you cannot focus too much. However, it's something which is in between the typical course that is delivered to the physics students and to the course which is delivered, for example, to the chemistry students. It's something in between. So regarding mathematics, is the same. They have they have more than 6 credits in mathematics, I guess, if I'm not wrong, but they have to start from the very beginning because, you can have students coming from a lyceum, but you can have also students coming from a technical course which are not confident with derivatives, with integral calculus, and so they have to start from the very beginning. But more or less is this the structure is of this type. So we have 6 credits for each course, so a total of 60 credits for each semester.
I'll take the turn around. Thank you for your presentation. It was very interesting as well. I will continue in the syllabus and in general in the day-by-day activity in teaching. And I'm worried about artificial intelligence. How are you dealing with this topic in the teaching and learning with your students? And how are you planning, if you are planning to put topics of artificial intelligence in the syllabus of your course?
So the topic of artificial intelligence is something which is included into the data science course, the one that you see at the second year, because in the data science course there are several examples on how to use data mining and artificial intelligence tools in order to extract and to predict the material's behavior. We have, as University of Bologna, regulation regarding artificial intelligence. So we know how and in which way we can use or not artificial intelligence to prepare, slide lectures and so on. Now it's becoming, so these are quite clear regulations. We have to cite, for example, if we use generative artificial intelligence, and this must be clearly stated and cited. Now it's becoming a little bit challenging to the problem of artificial intelligence very basically when I teach, the students make exams. For example, my exams of mechanics and thermodynamics is a written examination, and then there is an oral one. In the written examination, of course, if they have the possibility to use a mobile phone, they can solve everything with artificial intelligence now, and that's quite challenging. So for this reason, for example, when they do the written examination, they are not allowed to use the mobile phone. And in any case, if they try to do some non-legal approach, so to use another phone or something like that, we have also always oral examination. And in the oral examination, you cannot be helped by artificial intelligence, at least up to now. So we hope that this is not the case.
Yeah.
Kalini, just remember that I think that the physics course have the same structure of 3 years and 2 of master, because it's the Bologna process. Even the physics course have the same structure. I don't know how they do that, because here we have 4 and people asking for more hours of study. And my question. I'll go to make a commentary and forgot my question. It's about the this course. The other courses in the university, you have this student mobility between the universities from the Bologna process. You have the same structure for these courses. Students went to other universities to do the same. In these 3 years, do the same, have the same mobility, is it?
Yeah. Hopefully, in the sense that the universities among the Bologna process, all of them should have the same arrangement, 3+2. It's not always the case. For example, if you plan mobility with a university in UK, they have in some cases 4 years plus 1 year. And the same, for example, in Spain. In Madrid, they have 4+1. So you have really to arrange. Within the Erasmus project, when you promote the mobility of students, the important point for us is that they prepare what we call a learning agreement, which is a table in which you write the exams that you want to do in the partner university and the exams you plan to do in Bologna with the correspondence. And this kind of correspondence must be approved by the degree committee. So the degree committee should check if, for example, in the second year, a student will follow organic chemistry and a similar course at the partner university, and the syllabi must be compared. So in this way, we promote the mobility under the Erasmus.
Yeah. I'm not sure that you have to compare the 4 here with the 3 here, because what we call master here is a second cycle. So our path is 3+2, and then there is then there is the PhD. This is necessary, and the second cycle is much more focused on courses as well. In the total there are 180 credits in the bachelor, the first cycle, and 120 credits in the second cycle, and then there is the PhD. So I mean, also we had the 4-year bachelor, but then we needed to move from 3+2. So it was an extension of the 4th year in some sense. So it was 3+2 as a sort of reconceptualization of the 4-year cycle that we had until the Bologna process. Because typically the fourth year, when we had fourth year, there was only 1+ year for the dissertation, something like that. So 3+2 is the complete pathway. If I may, this is an issue because when we have Brazilian students in Bologna, for example, we have also the grant that are typically after the master, after our second degree, and it's a problem because there is not this comparison with your path, and this is always an issue because it's complicated to convalidate the master for you with the second cycle. This is something that is I had this issue very recently for this, so there is not this comparison. Different.
Thank you very much for your talking. And in fact, my question is related to this last point that Professor Liv told to us, because I'd like to know more about the kind of mobility that we can have between Bologna and a country like Brazil, that it's not it's not part of Bologna agreement, and there's no the same kind of curriculum that you have. Or in the case like collaborations in Brazil, it's much more focused in research and not student mobility. Or what kind of collaboration when you are in Brazil you are searching for in general terms?
Thank you. Yes, basically what I mentioned regarding mobility was mostly focused on credits mobility, so on the mobility of students for taking credits and courses abroad or for incoming students to us. In reality, we have several possibilities of mobilities for doing internship, research, for thesis, for example. And this is very used and very useful for our students in the STEM area. When I talk to you about mobility, it's a general plan that involves all the university. In the STEM area, you know, you have a very strict curriculum to follow, and it's sometimes difficult to find the very same course that you are expected to do in Bologna in a partner university. For this reason, for our students, it's probably more convenient to move for the thesis project. And we have several also funding for the thesis project. And under this general agreement that we have with several universities, included the Brazilian ones, we can also have some mobilities, for example, at PhD levels. And we can also try to find the correct financial support for this, for students from University of Bologna that want to come to Brazil, under some kind of call for application that we do as university in order to promote the collaboration between the different universities. For example, we have a call for application which is named Bando Strutture is named, that typically found projects related to mobility. For example, it founds the organization of summer school, winter school, or a mobility period of a PhD student that is sent from one department of Bologna to a partner university. This is really short mobilities, yes, of course. It depends on the funding, but...
Hello, Professor Daniela. Thank you for your presentation. I'm João. I'm a master's student here in University of São Paulo. And my question is related to the interdisciplinary approach that I saw that you value in this bachelor course. But I'm curious to know about the science education research or STEM research. Does the STEM program in the University of Bologna involve multiple departments, or is it only restricted to one department, such as chemistry education only being a problem, I don't know, an aspect of the chemistry department. And I would like to know the interdisciplinary in science education. Thank you.
So it's difficult to give you a general answer because it really depends on the kind of projects. So many of our research programs are funded within some international projects. Some international projects, like for example, European projects, can also involve more departments in the planning, but also not. So you can also have an international project funded within this department with the research which is carried out mainly in this department. So in this case, the research will be done in the department. Several projects are quite interdisciplinary because, as I mentioned, some societal important challenges like climate change, sustainability needs, of course, several expertise around the different departments, and so there is a strong collaboration. For the point of view of education here, in this particular example, we also have some projects regarding the education, for example, PLS, which is Progetto Lauree Scientifiche, projects about scientific degrees. And this is a project that we do since several years ago. And in order to promote and communicate the content of the STEM courses, and this is done in collaboration with the professors of the secondary level school, and those professors sent us a number of students that come to our lab and make an experiment in our lab, follow some lesson in our lab. So this is a very important project, and this is, for example, quite interdisciplinary.
I would have general questions of Bologna University. I take it very interesting that you got the 90th position in green metric ranking and the first one in Italy. Congratulations. I'd like to know, how can we do it in our country? We don't have a green metric in Brazil, since I know, but this is an international ranking, isn't it? Do you have any tips to give us to take this position? I mean, practical ideas. Okay, it's just to.
Then you will become a competitor, but okay. No, but there are some very practical things as far as I know. So there is in the governance of our university also a delegate for sustainability. And he has done several activities. He's a chemist, a colleague from the chemistry department. And for example, we have a number of cars that are used by university people to pick up, I don't know, the rector of the other university that comes at the airport and so on, only electric cars. Okay. We have also a big number of bicycle for sharing. And this is an activity which is as done in agreement with the municipality of Bologna. Bologna is one of the cities in Italy with the largest path of bicycle lines. And so bicycles are very widely used for the students. Another very practical thing, we don't have, so we still have in our departments the machines that deliver plastic bottle, but mainly we have this water delivery machine. So each student come with this borraccia, I don't know the English name, with this bottle, and fill the water. And so the number of plastic bottles is decreasing. And this is another very practical thing. Yeah, really very practical not so strong. There is also, this is also an important point. We have an agreement with the company that is in charge of the public mobility in the city, and also from the city to the different area close to the city. So each of us and the students, for example, up to a certain level of ISE of a family income, they do not pay anything for the public transportation. So they can move freely around the bus of the city for an agreement that we have with this company, which is driven by the municipality of Bologna. And as professors and staff, we have, for example, a very, we pay 1/2 of the total amount of a year, di abbonamento, so for the public transportation. We have special discounts on the public transportation as well. So there is a policy that goes through an increase of the public mobility, the green mobility, and so on. Yes, also solar panels. We have installed a quite large number of solar panels on the roof where it's possible. You know, Bologna is quite critical for this because it's a medieval city. So there is a strong regulation about the buildings. They cannot be changed. So the roof of the color must be red because Bologna is known as a red city. And as you have seen also from some picture, is a very old university, so you cannot install photovoltaic panels on the roof of the main city, but you can do it, yes, abroad. So, yeah. Also, the efficiency of the building has been improved. This is also the energy efficiency of the building. Yeah.
I think we need this type of solution here, isn't it? So, Professor Daniela, thank you very much for your talk, and come back sooner if possible for us. Thank you.
Now I wait for you in Bologna because I showed you some beauties of our university also in the movies.